So this problem might look familiar to you because it was on your homework last night. Okay, so let's go over how to do it real quick. What goes where? X plus 2 goes on the outside. And what goes underneath? Okay, good so far? Now, what's our first step? Divide, right? First term and first term. X cubed divided by x. X squared, where does it go? Above the x squared. Now what? So can I show you what I saw yesterday some? And then they tried to go on. Well, we only divided the first terms. We should only multiply the first terms, right? No. We divide the first term so we get a general idea. We get an idea of what that term is. And then when we go to multiply, we multiply every term. Please don't forget that, okay? Then what? Subtract every term, right? Subtract this term, subtract this term. That's a 0, which we planned, right? This is 2x squared. Now what? So we want to bring it down. Okay. Now we start over. Divide the first term by the first term. 2x. Multiply every term over here. So 2x times x. Good. 2x times 2. 4x. Excellent. And now subtract. That's 0, which we planned. This is 2x plus 4. Excellent. Now what? Start over again. 2x divided by x plus 2. Multiply 2 times x and 2 times 2. What's my answer? Okay, just as a quick aside, can I show you something that I saw yesterday also? What do you think about that? You don't need to do it, can you? And in fact, one of the people that I saw doing this, I asked them about that, and they said, if I don't do it every time, I'm going to forget when I need to. What did I say to that? Okay. Great. Okay? But this is the answer right here, right? This main part is the answer. You can put that if you need to, but that's our answer, right? So I want to do this problem again, but this time I'm going to do with synthetic division. Do you remember what I told you when we started this whole division thing? Why I didn't just teach you synthetic division first? Because it's so much easier? Not necessarily. Because it doesn't work every time. You remember that? So you guys all had good guesses, for the record. They were all good guesses, okay? Because a lot of times if I have to teach you both, I'm going to probably teach you the harder one first, or you won't ever do it, right? But synthetic division doesn't work every time. So before we even go on, I need you to make sure you understand when it works, when you can use it, okay? I'm telling you right now it works on this problem. It would also work if I was dividing by x minus 1. It would also work if I was dividing by x plus 7. It would also work if I was dividing by x minus 12. It would also work if I was dividing by 2x plus 3. It would also work if I was dividing by 5x minus 4. When does it not work? X squared. X to the third. X squared and an x in what I'm dividing by. Okay? Only when it's x plus 2 or x minus 4 or 2x plus 3 or something like that. Is that fair? Okay. So on your problem on your homework last night, there was several that you could not have done synthetic division with, right? Okay, so here's what we're going to do. First of all, let's figure out how to set this up. Okay? Here's how we start, first of all. Somebody earlier said, that looks upside down. I was like, uh-huh. That's okay. I need 2 rows. I need to be able to write 2 rows right here, just for the record. Okay? So we've got an outside and we've got an inside. Are you clear about that? What do you think goes on the outside? It's what we're dividing by, right? That's typically what goes on the outside. When we're doing synthetic division, we take what we're dividing by and set it equal to 0. And they said, oh, that's just the opposite. That's true, isn't it? Can we always just think of it as the opposite of whatever's here? No, right? What if this said 2x minus 1? Could I just put a 1 over here? Not if it has a 2x minus 1. I've got to set it equal to 0 and solve. So if you want to think of it as the opposite, maybe. I'd prefer you think of it as set it equal to 0. Oh, okay, it's the opposite. Go. Does that make sense? I don't want you to mess up because you forgot to do this. But if you know that this is just x plus 2 and you know it's going to be negative 2 out here, I'm fine. Do you see when the problem comes? Problem comes is when it's 2x minus 1. I can't just throw a 1 up here, right? Got to set it equal to 0 and solve it. You okay with that? Okay. So negative 2 goes out here. Watch what goes inside. Just watch. You can write it in a minute. What goes inside? Just the coefficients. I could tell there were several of you trying to get the word in your, because you're like, something. Coefficients is correct. Okay? It's the coefficients that go inside. Okay so far? Now, I really, 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 really have to work with myself to go slow enough. Because once you figure out how to do this, it's going to go so fast. So I'm purposely going super slow right now. Is everybody okay with that? The other thing that I want you to do when we first do this first example is just watch me. I promise I will let you write it down in just a minute, but I just want you to watch because it goes so fast. I don't want to lose you in the writing. Everybody ready? Okay. Whatever this number is right here, pull it down. Whatever it is, pull it down. Okay? Multiply. What do you get? Write it right there. Add. Start over. Multiply. Write it right there. Add. Start over. Multiply. Negative 4. Write it right here. Add. This box right here is the remainder. This first term right here is the constant. Every time. The term right next to that is the x term. Every time. The term right next to that is the x squared term. Every time. If there was another one, it would be to the third and then x to the fourth and x to the fifth. So start at the remainder box. The first one's always the constant, then the x squared term. Okay? So what's the answer? Look. Copy it. Got it? Ready to go or wait? Yes, ma'am? I'm going to go ahead and write the next problem while you're finishing up, and then I'll let you copy that problem before we go on. Ready to go on? Next problem? Okay. Set it up for me. What goes on the outside? Positive 3? Now, did any of you come over here and write x minus 3 equals 0, or is that something you can do in your head? Good. Either way is good, right? Okay. What goes on the inside? Negative 1, 4, y is 0. You remember when we did long division, we said we had to make sure every term is represented when we write it out? Same goes for synthetic, okay? Same goes for synthetic. If we've got an x to the third, we need an x to the third represented, and an x squared, and an x. And if there's not one, we got to put one, okay? And then draw your remainder box under your last term. You ready? Are we going a little faster this time or no? Just a little bit? Okay. Bring it down. Multiply. Write it right here. Add. Multiply. Write it right here. Add. Multiply. Write it right here. Add. If this is my remainder, and this is my constant, and this is my x, and this is my x squared, what's my answer? X squared. Oh, negative x squared, huh? Negative plus x plus 3 plus 18 over x minus 3, right? What I was originally dividing by. How you feel about this? Okay. I would like to show you the way that one of the problems shows, or several of the problems show up in your homework. Can I do that? Okay. It's different, isn't it? The directions say, evaluate this problem for the given value using synthetic division. So what do you think we ought to do? How do you think we ought to set it up? Negative 2 on the outside? Yeah, it already tells you what x is, right? So we go straight to negative 2. There's nothing to set equal to 0 and solve because it's already solved, right? What goes on the inside? 0, 2, negative 10. What was not there that we had to provide a space for? X squared. Okay? How fast can we go? 1, negative 2, 4, negative 8, negative 8, 16, 18, negative 36, negative 46. Can we go that fast? Could I go faster if I tried? Probably, but what would I do? I would mess up. I would miss a negative sign. I would miss multiply. So don't go fast just to go fast. Okay? Yes, we want to get our homework done quickly. Yes, we want to master the concept, but we also want to get the right answer. Okay? Remainder, constant, x squared. So x cubed plus 4x squared minus 8x plus 18. Either way is fine. Over what? X plus 2, right? Now, a couple things about this first of all, okay? If I say to you, we're doing synthetic division and we're going to evaluate this at the given value for the given equation using synthetic division, you want to just automatically use synthetic division because that's what it told you to do, right? How do you normally evaluate a function at a given value? If I say evaluate this function at x equals negative 2, what do? Yeah, don't you just plug negative 2 in anywhere there's an x? Can I show you something math cool about this? Negative 2 to the 4th power plus 6 times negative 2 to the 3rd power plus 2 times negative 2 minus 10. Negative 2 to the 4th power is 16, right? Because I've got negative 2 times negative 2 times negative 2 times negative 2. That's 4. That's negative 8, and that's 16, right? Negative 2 to the 3rd power is negative 8 times 6 is negative 48. 2 times negative 2 is negative 4 minus 10. 16 minus 48 minus 4 minus 10 is negative 46. What we did right here was write the answer of the synthetic division problem. What the directions asked us to do was evaluate the given equation for the given value using synthetic division. So when you do these problems, there's two things that I actually want you to write as part of the answer. The first thing is what you actually get when you do the synthetic division, because that's what we're practicing on right now. But I also need you to realize that if you evaluate this function at negative 2, what do you get? The remainder. We get negative 46. Okay? What's funny is that a lot of times now that people know the synthetic division, they don't want to do this anymore because they think that's harder. I didn't use a calculator. It would have been a lot faster with a calculator, right? But evaluating a function at a specific value, what you're going to end up with is what the remainder is. And I think that's kind of math cool. Okay? So, what are you going to mess up on if you mess up on these problems? What are you going to forget to add? A placeholder, 0, right? So when you're copying down the problems, make sure you're noticing, oh, this starts with a 4. I better have a 4, a 3, a 2, and oh, I don't have a 2. Better have a 0. Okay? The other thing that I want you to keep in mind is that be patient with yourself. Okay? If you go back and look at my notes, for the first time I had this problem, I missed the negative sign. Because I'm a human, right? Now I want to be at least as good as I possibly can be in front of all of you, right? But sometimes I mess up because I'm a human. I don't want you to mess up. I don't want to mess up. Okay? So go slow enough so that you make sure that you are catching all of your negative signs especially. Okay? And please remember that, here's the other thing that I saw that was kind of funny. If this is a negative 2 right here and this is a 1, don't write a negative 2 right here. Okay? Whatever's here, bring that straight down. You're not bringing this diagonally down. You're bringing this number straight down right here. Okay? So be patient with yourself on this. Make sure that you're including placeholders if you're missing a term. And see if you can get this done for the bell. How about that? Mark, get set, go.